This lesson is on trig functions and special angles. So before we try to solve problems of this type, we first need to do a quick review of our two special right triangles and also of our unit circle. So our two special right triangles, in previous videos I've shown how those are derived. So this time I'm just going to go ahead and draw these triangles. So this is our 30, 60, 90, and our 45, 45, 90. That's in degrees. If we're working in radians, this would be, actually I'm just going to draw that triangle again, show it in radians. 30 degrees is pi over 6 radians, and 60 degrees is pi over 3 radians. And there's our right angles. So opposite our 30 is 1, opposite our 60 is root 3, and opposite our 90 is 2. For our 45, 45, 90, opposite both 45-degree angles is 1, and we have square root of 2 here. So these are the special right triangles that we will be working with. We will also be working with our unit circle. So the unit circle has a radius of 1. Has a radius equal to 1. So if I wanted to draw this radius here, call that point xy, this would be our unit circle. So let's look at the unit circle using degrees first. So this would be 0 degrees, 90 degrees, 180 degrees, 270 degrees. So it goes counterclockwise for positive angles, and then if you go clockwise, you're dealing with negative angles. And negative just represents direction. It doesn't mean that it's a negative value. It's just the direction that you are moving. So in radians, we would have 90, which is pi over 2 in radians. 180 is pi, and 270 is 3 pi over 2. And that's in radians. So quick review, if you don't know how to convert from degrees to radians, if we have 90 degrees, there are pi radians in 180 degrees. So that's your unit converter for going from degrees to radians. And I'm just going to simplify that, and that's how I get pi over 2. Okay, so let's start by identifying making sure we know how to identify coterminal angles. So if I ask you to graph, say 135 degrees, that means you would start here and you would move around the unit circle, and 135 degrees would be roughly, let's use a different color here, roughly right about there. But whenever we are solving these problems, we want to solve them in terms of their reference angles. And your reference angle is the angle that is made with the x-axis. It's always, always, always the angle made with the x-axis. So this would be my reference angle for 135 degrees. So my reference angle would be 45 degrees. So if I were to solve for, say, the sine of 135 degrees, that would be equivalent to the sine of 45 degrees, because that is its reference angle. Now, there is a positives and negatives change as you move throughout these quadrants. And to understand why that is, we kind of need to understand how these points are defined along the unit circle. So if you already know that, feel free to fast forward in the video if you already know how to identify where things are positive and negative. But if you don't, keep watching because I'll go ahead and review that. Okay, so again, here's our unit circle, and we're going to call this point on the unit circle x, y. And I'm going to go ahead and create this right triangle. So again, unit circle has a radius of 1, so we know the hypotenuse is equal to 1. Here's our value of theta. So we're going to define these this ordered pair using sine and cosine. So remember, sine of an angle is equal to the ratio of its opposite side to the hypotenuse, and cosine of an angle is equal to the ratio of its adjacent side to the hypotenuse. So if we solve this for the sine of theta, you can see sine of theta is equal to opposite over hypotenuse. Well, if this is the coordinate xy, this value is x, this value is y, so opposite over hypotenuse is equal to y. So we can say that the sine of theta is equal to y. Cosine of theta is equal to adjacent over hypotenuse, which is x. So we could just as easily define this ordered pair as cosine x sine, cosine theta sine of theta. So cosine theta sine of theta. And that's another practical way to identify this coordinate. So if we look along the unit circle has a radius of 1. So that ordered pair right here is 1, 0. This ordered pair is 0, 1. This ordered pair is -1, 0. And this ordered pair is 0, -1. So for these coordinates along the unit circle, keeping in mind cosine of theta is equal to x and sine of theta is equal to y, these help us to evaluate any angles that fall directly on one of these four quadrants. So if we are looking at cosine of pi, well, okay, cosine deals with x, pi is right here on our unit circle, so cosine of pi is -1. If we are looking for cosine of 3 pi over 2, well, this is 3 pi over 2 radians, that's 270 degrees. So we're still dealing with cosine, so cosine is equal to 0 at that point. Let's look at sine of 90 degrees, or sine of pi over 2. Pi over 2, 90 degrees are both the same. So sine is equal to y. Y is equal to the sine of theta. So the sine of 90 degrees is just 1. And the cosine of 90 degrees is 0. So what about maybe cosecant? So remember, cosecant is equal to 1 over sine. That's one of your reciprocal trig functions. So cosecant is equivalent to 1 over the sine of theta. So if we're looking for, say, the cosecant of pi, that's 1 over the sine of pi. Well, the sine of pi is 0, so that's 1 divided by 0, which is undefined. So anything divided by 0 is undefined. But if we were looking for the secant of pi, that's equivalent to 1 over the cosine of pi. And we know the cosine of pi is -1. So -1. So that gives us -1. Okay. So if we were looking at these different quadrants, knowing that cosine deals with x and sine deals with y, in this first quadrant, x and y are both positive. In the second quadrant, x is negative and y is positive, which means if you have an angle in this quadrant, sine would be positive because sine deals with y, and cosine would be negative. So in this quadrant, sine is positive and cosecant is positive because cosecant is just 1 over sine. In this first quadrant, everything's positive, so all things are positive. In this third quadrant, sine is negative and cosine is negative. So the only thing that would be positive here, remember tangent of theta is equal to sine over cosine. So if these are both negative, a negative divided by negative is positive. So tangent is positive in the third quadrant, and its reciprocal, which is cotangent. And in the fourth quadrant, we have positive x and negative y, so cosine is positive in this quadrant, along with secant. Way to help you remember this, which I know it's not true, but if you think of it as all students take calculus, everything's positive here, all, sine students take tangent calculus C. So that helps you identify where things are positive and negative. So now that we're a little bit more familiar with the unit circle and reference angles, now we can go ahead and start looking at questions like this. So this question, and I'm going to go ahead and clear some of this stuff out. So this question is asking us to find, I guess I should have kept our special right triangles, but that's okay. Delete that. So I'll go ahead and draw those back in. Opposite 30 is 1, opposite 60 is square root of 3, opposite 45, 1, 1, square root of 2. Okay, so now we have that back. So step 1 is to go ahead and plot this point on your unit circle. So negative 330 degrees. That means I start here. Negative means I go clockwise. So negative 90, 180, 270. So negative 300 is going to fall somewhere around here. So that's going to give me negative 300. So my reference angle is 60. Because if I were to go all the way and complete the unit circle, that would be 60 degrees. So this is 300, that's the remaining 60. So there's my reference angle. It falls in the first quadrant. So I know that my answer is going to be positive because everything's positive in the first quadrant. So to find the exact value of sine of 330, I could just find the value of sine of 60. Remember, sine is equal to opposite over hypotenuse. So square root of 3 over 2. And that is the exact value. Exact value is code for don't use a calculator. Okay, so this next one, find the exact value of cosine pi over 2. So pi over 2, remember, is 90 degrees, which is here. Remember, this ordered pair is 0, 1. And we know that cosine of theta is equal to x. So cosine of 90 is 0. Okay, let's look at another example. Aren't these fun? I think these are kind of fun. Okay, so here we have cosine of negative 3 pi over 4. So negative 3 pi over 4 means I'm going this direction. And I know for some of us, we're a little bit more comfortable working in degrees than we are working in radians. The ratios are going to be the same whether you solve these problems using degrees or radians. So it's perfectly okay to convert this to degrees and then solve the problem that way. So negative 3 pi over 4 is negative 135 degrees. I know that because, and I can do that quickly because I know that pi over 4 is 45 degrees, and 3 times 45 is 135. And another way, just in case you're not familiar with converting from radians to degrees, we would multiply by 180 degrees over pi radians. So that pi cancels, and 180 divided by 4 is, or sorry, for some reason I lost my 3 there. 3 times 180, that makes more sense, divided by 4 is 135. Okay, so negative 135, we start here. That's 90, and that goes to 135. Well, we have to figure out our reference angle, which is always made with the x-axis. So again, that's our 135 degrees this direction, so that's why that's negative. So our reference angle, 180 minus 135, which is 45 degrees, or pi over 4, whichever you want to work with. So we're in the third quadrant, so we need to think about, before we solve for this ratio, because it's so easy to forget the sign, I always do the sign first. Is cosine positive or negative in the third quadrant? All students take. So take, that means tangent is positive in this quadrant, which means everything else, well, cotangent is also positive, which means sine and cosine are negative in this quadrant. So I know that my answer is going to be negative cosine of my reference angle, which is 45 degrees. And then that's where these triangles come into play. So cosine of 45 degrees, adjacent over hypotenuse. So that's 1 over square root of 2, and that's negative. Now, you should go ahead and rationalize the denominator. It's just kind of considered bad math manners to leave that radical in the denominator. So I'm going to multiply by square root of 2 over square root of 2. It's equivalent of multiplying by 1, so that's allowed, which gives me negative square root of 2 over 2. There you go. All right, let's do one more. So sine of 3 pi over 2. 3 pi over 2 is 270 degrees. In 3 pi over 2 radians, it falls right here. That is, we're dealing with sine. Remember, sine is equal to y on the unit circle, only on the unit circle. Sine is equal to y, so this ordered pair is 0, negative 1. So that's equal to negative